My name is Aditya Chandurma. I'm the team lead of Team WriteMate, and our team is participating in the SIH under the problem statement SIH 25123. The problem statement title is Student Innovation. The theme is Smart Education. The problem statement category is Hardware. The team ID is 62263, and the team name is WriteMate. So let's get into the fact that what WriteMate actually is. So WriteMate is the assistive technology that is based on CNC systems. So it is designed to empower the senior citizens, individuals with the disabilities or people with injuries that prevent them from writing. It enables them to physically participate in the exam and write on the paper independently and physically. So what is the need of the WriteMate? You might ask. So as of now, currently the many students who cannot write rely on scribes. So what scribes is? So scribes are the people who who transcribe their gestures or voice command or whatever these people want to communicate with into the text that they write into the paper. So these are the people who write behalf of these people. So the issue in this system is that there is the reachability problem. First of all, like scribes may be located very far from the student, sometimes hundreds of kilometers away, so this might cause inconvenience to the examinee. Also, there is misinterpretation issue as well, like error can occur during the transcription due to misunderstanding between the student and the scribe. Also, during the research, we have also found out that there is sometimes biasness also introduced during the examination, in these kind of examination especially. Like human scribes may unintentionally introduce the bias during the examination process. Also, the privacy problem is also there. Like a student may feel uncomfortable sharing their answers with the another person as well. These kind of issue also can be happen during the examination. So how RightMate is addressing these problems? Uh, so RightMate, when deployed, RightMate will be available in every institution. That will eliminate the reachability problem. So this will solve the first issue, the major issue actually. The second issue is that the problem of inaccuracy, misinterpretation. The RightMate will solve it because as of now our model is trained and it is shown that it is delivering 96% accuracy in converting gesture to text. So and how the machine is actually working? So in the first hand, the user will there will be a user interface provided to the user where the user will interact. It will be a website that will be displayed on the screen on our machine, and the user is provided with you can say selections, like they can select in which mode they want to transcribe, like voice or gesture. Also, they can also select the type of language they want to choose. Also, they can also choose the font style, font weight, and the font family, etc. Kind of stuff. Also, they can select as per their need. And after the selection, they can start the capturing button. Here is the start capturing. Start capturing. So once this capturing is start, either depending on the selection, either voice or gesture will be taken from the user. If the voice command is provided, the microphone will activate. If the gesture is selected, the camera will activate. Suppose we are capturing the gestures, so our machine will understand the ISL command, the Indian Sign Language command. We have trained a model on that, so machine will start capturing with the camera, and after capturing those gestures, the machine will transcribe those gestures into text. This is the user feedback part. I will come to this later. So once the gestures or voice is provided, this data will be converted into text. Now, when this text is converted, the this text will be converted into the SVG file. So what is SVG file? So SVG file is the support vector generation file. So this is the intermediate step before the conversion of the G code in our machine. So when the SVG file is converted, it will then move to the other stage, that is the G code generation. When the SVG file is converted into G code, this is the actual geometric code that the machine understands, our writing machine understands. So the gesture or voice is now ultimately converted into the G code, which is then fed into the machine. When the G code is fed into the machine starts physically writing on the paper.
So I'm Devanshi, and I'm going to explain the flow of our website. So this is the landing page from where the user will interact. Here, there is a small toggle button which changes the theme. Then we have some core features of our website here and some pictures of our project. This is our machine, and this is the process of how it works. So let's just sign in. If the user is already registered, we need to sign in, and if you want to create a new account, then we need to sign up over here. After login, the user comes to this dashboard section where they can see all of their documents that they have previously written along with the project title and when it was created. Then if he wants to create a new document, he would select here and this write section would be opened. Now here he's given two options how he wants to give their commands. If he selects voice, then a microphone panel would be opened, and if he selects gesture, then a camera panel would be opened. And after all this process is completed, an SVG file would be downloaded at this particular dashboard. Then we have this document section, which makes it easier for the user to create changes into their documents. If they want to create any change or delete the file, you can do it from here. Then we have this about us section, which tells us about the mission of our team, that is to make everyone able to write so that they do not have to be dependent on any other person. This is about our mission. And then we have this contact us option.
Hello, I am Akash and I'm going to explain how the backend of our project works. So when a user come to our website, he have two options for input, whether he can choose voice or gesture. If the user chooses voice input, the website turn on the microphone. We can keep the process very simple. When the user say start listening, the system begin recording, and when the user say stop listening, it is stop. The spoken word are sent to the backend where they are converted into the SVG file. At the same time, the file is automatically downloaded onto the user device for quick access. In the similar manner, if the user chooses the gesture option, the website turn on the camera and start tracking the hand movement. These hand gestures are recognized and then converted into the SVG file, just like the voice case. The file is also saved in the database and downloaded on the user system. In both cases, whether he can choose a voice or gesture, the backend ensure that the SVG file are stored properly and remain accessible on the user dashboard at any time. So now I quickly demonstrate this process so you can see it in action. When the user click on the start voice, the script is start running on the backend, and before the user say start listening, the text is unrecognized or it being ignored, as you can see on the terminal. When the user say start listening, so listening is enabled now. After that, anything the user will say, it will recognized. Yeah, and you can also verify it by on the dashboard, where the in the input field you can see whatever you can say it will be right. So you can cross verify the what you are saying is properly recognized or being saved or not. So for saving, you can simply say stop listening. So the listening is disabled now, as you can see. And if we save the if you want to save, we can simply close the button, and the SVG file is downloaded, as you can see that, and we can simply save it, and we can also see it. Yeah, the SVG file is saved now. Okay. In the below, when the user click on the gesture button, it will redirect to the next page, where I have to give the gesture as an input, and it will be recognized and counted into text. Firstly, we have two options: recognize or train. Firstly, I have to show how to train. Let's suppose this is V. This is C. This is 5. This is 1. And in a similar manner, it will be recognized 1, 5, C, V. So that's how we can recognize the text by the input as a gesture. And here we have simply add a button of generate SVG. When we have clicked, it will be converted into the SVG as an output, and we can simply download it from here. It will be downloaded and save on the user dashboard, and we can simply see it from here. So that's all from my side. Thank you.
Hello everyone, my name is Abhay and this is a quick demo of the core logic behind our project. So our solution works on two main inputs, hand gestures and voice commands, and converts them into digital text output in SVG format. Let me explain you how. So in the first part, we have our hand gesture recognition code over here. As you can see, we are using OpenCV, MediaPipe and NumPy to detect and classify hand gestures. So what happens here is the camera continuously captures and MediaPipe identifies 21 hand landmarks. From these hand landmarks, we calculate a distance matrix over here, which normalizes the distances based on the palm sizes. And during training section, we store the matrix values for alphabets A to Z and digits from 0 to 9, as you can see over here, like that. And after this, in the recognition part, we compare the live gesture metrics with the trained ones. And if the error is within our threshold limit, we classify it as a letter or a digit. Otherwise, it is classified as an unknown string. Finally, the recognized sequence of gestures is then converted into text. And after that, it is converted into a SVG format. So it can be displayed or can be printed simply. Okay, now moving towards the voice to text conversion part. So here it is the code. So we have used the speech recognition library from Google for capturing voice. The microphone listens continuously, converts the speech into text, and keeps appending it. If the user says stop listening over here, the system finalizes the text. Just like in the gesture part, the recognized text is now written into an SVG file. This ensures that whether input is through gesture or voice, the final output is always text in a structured format that can be displayed or further converted into the G code conversion machine. Now, moving forward. So, the main core, the main idea behind this approach is that both gestures and voice command converges into the same output pipeline. So, it makes the system accessible and inclusive to a person with different abilities. Thank you.
Shiroda, and I will be demonstrating the working of the project. So let's move to the software which we are using, which is InScale. So basically, this software is used. We can to print the used so that we can give our text or images which are converted into SVG format, then given to our machine. And let me show you the machine.
So this is our setup. This is the microprocessor. Here are the motors, the stepper and servo motor, which function together so that the pen can move all over the sheet. And these are the basic connections. For now, we are using our laptop, but for the next step, we will be switching to the Raspberry Pi 5 and the screen, which will be mounted in front of here, so that the user can, and the website will run on this, so that the user can directly interact on it. Let me show you the Pi 5 and screen as well, which will be mounted here. So this is the Raspberry Pi 5 mini computer, and this is the same. This screen will be mounted in the casing which of our hardware here. So now let's again move to the Inkscape software to demonstrate how the project functions.
Now let me demonstrate how an image is printed. First of all, let me add an image over here. A simple image. I just copy and paste over here and resize it. Place it over the paper. Currently it is not SVG, so let's convert it into SVG first. Trace bitmap and apply here. And let me delete the old image. And this is SVG. So now we can print it just like the same. We printed the text extensions, X0 control, and we are set to go. Clicking on the